Welcome back to AI on AI, where we peel back the layers of cutting-edge research so both tech architects and business decision makers can act on it. Today, we're diving into self-questioning language models, or SQLM, straight out of Carnegie Mellon.
Thrilled to be here. This paper landed on my desk, and I instantly thought, forget data-driven, we're talking model-driven growth now.
Same reaction. Technically, it's fascinating because it reframes post-training as an asymmetric self-play game. Think AlphaGo. But instead of black and white stones, we're juggling math problems, code snippets, rewards, and KL penalties.
And let's be honest, post-training data is a budget black hole. If a model can mint fresh, useful data on its own, that's a CFO's dream.
Plus, in EdTech, we've seen teachers burn weekends curating problem sets. A self-questioning model could churn out adaptive curricula on the fly.
Hang on, everyone's cheering. But remember Malcolm Gladwell's line, "We learn by making mistakes, but we also learn the wrong lessons." If the model keeps rewarding itself for flawed logic, you scale error, not intelligence.
Love the healthy skepticism. Let's unpack the mechanics first. How does this proposer-solver loop actually work under the hood? Picture a single pre-trained language model cloned into two personas. The proposer is prompted with a domain, say, 3-digit multiplication, and it generates a question. The solver, same base weights, attempts an answer. Rewards flow via two unsupervised channels, majority voting for small generator verifier gaps, unit test pass rates for code.
Technically, they use PPO with a tiny KL term, 0.001 in the paper, to keep the policies tethered to the base model while still exploring. It's like giving a kid a long leash, but not letting them sprint into traffic.
The clever bit is the proposer reward. It's 0 if all solver samples agree or none agree. That forces a curriculum, Goldilocks problems, not too hot, not too cold.
Strategically, that means your model auto-discovers the 80-20 sweet spot of question difficulty without a human teacher. In business terms, you now have a perpetual training engine that balances exploration and exploitation.
But you're assuming the majority is right. In echo chambers, majority consensus can be spectacularly wrong. That's a governance red flag.
True, yet empirically the gains are real. Qwen3b jumps from 79% to 95% on multiplication with 0 new human data. That's not trivial noise. Let's zoom in on one deep dive. Generator verifier gap. Why does it matter? Think of it like hashing versus mining. In addition, verifying a SHA-256 hash takes microseconds. Generating a valid Bitcoin block is arduous. In coding tasks, writing a correct solution is hard, but running unit tests is cheap. SQLM exploits that by letting the proposer supply test cases, instant verifier, low gap.
And when the gap is small, arithmetic for example, you lean on majority voting. It's less elegant, but pragmatic. The brilliance is choosing the right heuristic per domain.
Building on that, we piloted a math tutor chatbot using SQLM inside a sandbox. In 2 weeks, it produced 10,000 algebra problems of graded difficulty, and student scores improved 7% on standardized practice sets. No extra content writers hired.
I can echo a similar ROI story. A supply chain SaaS platform integrated a self-play bot to generate synthetic exception handling scenarios. Support ticket resolution time shrank by roughly a quarter because the model had pre-trained itself on edge cases no one thought to label.
Those are powerful numbers, but let's tackle operational challenges. Updating the proposer every 5 steps seemed magic in the paper. Why not every step?
If you update too frequently, the task distribution shifts faster than the solver can adapt. Classic non-stationary target problem. They tried frequency equals 1 and saw higher variance, almost like overfitting to novelty.
Exactly. Reinforcement learners hate moving targets. 5 steps is empirically a sweet spot, enough stability for the solver's gradient estimates, enough drift to keep the curriculum sharp.
But from a compliance standpoint, you now have a moving distribution of prompts. Some could turn toxic. Who's gating the proposer?
That's where a lightweight human-in-the-loop or guardrail policy slots in. You don't need to label every sample, just audit a slice. Think Sarbanes-Oxley for data ethics.
We integrated a sentiment and safety filter post-generation. Anything flagged gets tossed before it reaches learners. Adds milliseconds, saves headaches.
Second technical deep dive, reward hacking. The majority vote can be gamed. What safeguards exist? They include an entropy-based intrinsic reward clamp. If the model becomes overconfident, entropy drops too low, the KL penalty kicks harder. That reigns in collapsed modes.
Plus, for code, they use pass fraction, not binary pass-fail. That smooth reward curve discourages trivial hacks like return 0 that accidentally pass one edge test.
Still, consider Goodhart's law. When a measure becomes a target, it ceases to be a good measure. We may need ensemble verifiers or randomized holdout tests.
I see nods. Let's pivot to business scalability. Does this replace RLHF?
Not entirely. Think of SQLM as the gym, RLHF as the nutrition plan. Self-play bulks up reasoning muscles, but alignment to human preference still needs curated signal, especially for brand tone or legal compliance.
And we shouldn't ignore compute cost. Self-play burns cycles. Each training step spawns n samples. In the paper n equals 4, push that to 16 and your GPU bill spikes.
True, yet relative to a data labeling pipeline employing hundreds of annotators, GPUs look cheap. One retail client redirected 10% of annotation budget to self-play compute and netted a 12% accuracy gain on product matching without headcount expansion.
Another real-world twist, multilingual markets. Self-play can generate problems in low-resource languages because the base model already has latent knowledge. That's a force multiplier for global edtech.
But multilingual self-play makes auditing tougher. A toxic prompt in Swahili could slip by if your safety classifier is only English-centric. That's the bottleneck we might be overlooking.
Interesting contrarian angle, auditing multilingual generated data. Let's talk future implications. Where do you see SQLM in, say, 3 years? I foresee meta-proposers, models that learn how to refine their own prompts, maybe via evolutionary strategies. Prompt engineering becomes self-engineering.
And in MLOps, SQLM loops could run continuously in production, similar to Canary releases. The solver's weights update nightly, proposer weekly, with automated rollback triggers.
Strategically, firms will treat synthetic self-play data as an asset class. The question on earnings calls won't be, how big is your data lake, but how good is your self-play curriculum?
Educationally, adaptive textbooks that literally rewrite themselves overnight based on cohort performance, that's not sci-fi anymore.
Before we pop champagne, remember Einstein's quote, "The measure of intelligence is the ability to change." Great, but change in the wrong direction is catastrophe. We need governance frameworks that evolve as fast as the models do.
So rapid innovation married to agile governance. Sounds like the mantra. Final quick takes, 1 sentence each. Biggest opportunity or risk with SQLM?
Opportunity, unlocking perpetual upskilling without perpetual labeling.
Technical thrill, bridging exploration and exploitation via asymmetric self-play.
Operational win, shifting spend from static data pipelines to dynamic compute.
Societal upside, truly personalized, equitable education content.
Scaling bias and toxicity faster than we can audit.
There you have it, the promise and the pitfalls of self-questioning language models. As Drucker famously said, strategy is a commodity. Execution is an art. SQLM could be the next brush. Just be sure you're painting on a safe canvas. Thanks for tuning in. Until next time, keep questioning. Welcome back for part 2. Let's roll up our sleeves and dissect how teams can actually build and ship a self-questioning language model pipeline. First pillar is prompt architecture. The paper's authors used under 512 token prompts with strict format constraints, then let the proposer improvise inside that fenced playground. We've replicated that by templating YAML prompt files so product managers, not just engineers, can tweak the topic or complexity.
Right, and under the hood we run 2 parameter shared actors in a single process with a role tag at generation time, less memory overhead than 2 separate models. A fast identity switch is simply a prefix like proposer or solver injected into the hidden state.
For execs listening, that translates to lower GPU hours. On an A100, a 7B model cloned into two personas consumes about 14 gigabytes rather than 2 times 14 gigabytes because the weights are shared, so your infra spend doesn't double.
Implementation trick number 2, batched rollouts. Instead of one proposer question per PPO step, we push 64 questions through in parallel. That's how we reach 100 total RL steps overnight, which is key for agile product sprints.
Building on that, reward shaping is where teams trip. The paper uses KL weighted loss of 0.001 to keep generations on brand. We found a heuristic. Set KL coef such that the average KL divergence per token hovers around 0.3. If it spikes, you're drifting into nonsense. If it drops, the model's stagnating.
And don't forget entropy monitoring. If entropy 1.0 token bits for several batches, the proposer's fallen into trivial questions. Time to reset with temperature bump or larger top P.
There's also the compute data seesaw. We log the ratio of PPO policy updates to unique tokens generated. Once that ratio exceeds 0.2, we're overfitting the self-generated corpus, and we pause training to regenerate fresh problems.
Let me translate that metric to business speak. If your innovation index, updates per novel token, creeps too high, you're paying compute for diminishing returns, so you schedule a regeneration cycle.
Practical application time. Give us a live customer story.
A fintech firm rolled out SQLM to generate synthetic fraud scenarios. They wired the proposer prompt to unusual transaction patterns, then used solver accuracy as a gating signal. Within a month, detection recall improved roughly 11 percentage points, all without exposing real user data. Huge for compliance.
Tech nugget there. They replaced unit tests with a deterministic fraud rules engine for verification. Generator verifier gap stays small because rule checking is cheap.
I see your success, but a contrarian note. Synthetic fraud patterns can drift away from real attacker behavior. They address that via a weekly real-to-synthetic distance metric, KL divergence of feature distributions, and inject 5% real-labeled cases when drift exceeds threshold.
Speaking of drift, OPS-wise, we deploy the self-play loop as a micro-batch job on Kubernetes. The proposer-solver pair writes to a Redis queue. A verifier worker consumes, scores, and logs to a feature store, fully observable with Grafana dashboards.
From a CIO viewpoint, that modular approach means any legacy system can subscribe to the feature store and benefit. No big bang refactor.
Now deep dive number 2, multi-domain curricula. The paper sticks to arithmetic, algebra, coding. We extended the schema to include domain tags. The proposer prompt contains a JSON header, domain, legal contracts, difficulty 2. Solver performance per domain feeds back into a bandit algorithm that upsamples underperforming tags, effectively automated curriculum balancing.
That bandit is just an epsilon greedy policy, where reward is held out benchmark F1. Simpler than RL on RL, yet gives 6% lift in our legal summarization pilot.
But legal text introduces a massive generator verifier gap. The model can draft a clause, but correctness checking requires domain experts. We mitigate by integrating a rule-based contract parser that spots structural violations, then escalate only ambiguous cases to humans.
That's clever. Human review becomes exception handling, not the main pipeline. What about scaling beyond a single GPU?
We use parameter-efficient fine-tuning, LoRa adapters per role. You freeze the base model, attach 8-bit adapters, and only those tiny matrices update. Then you can shard across 4 mid-range GPUs, rather than renting a pod of A100s.
LoRa also lets you A/B test quickly. Spin up a new adapter with a different proposer reward, say entropy bonus, and compare offline metrics without retraining from scratch.
Strategic takeaway. Parameter-efficient tech shortens your idea-to-iteration loop, much like Agile for software. That's priceless in competitive markets.
One more business example. An HR platform used SQLM to auto-generate star-formatted interview questions. Proposer prompt targeted leadership, teamwork, adversity scenarios. Solver was replaced by a retrieval model that checked novelty against existing questions. Result, recruiters spent 30% less time prepping interviews.
Potential landmine, though, cultural bias in generated questions. They countered by adding a fairness classifier into the reward. Any sample flagged for gendered language got a 1 booster. Simple, but effective.
We're nearing the end. Quick lightning. Top implementation gotcha you've each hit. Forgetting to detach gradients when sampling multiple solver answers. Computational graph, blue VRAM, sky high.
JSON parsing failures from stray commas in proposer output. We solved with regex sanitizers before the solver consumes.
Misaligned timeouts. Unit tests that hang will stall your RL step. Sandbox them with hard 3-second limits.
And mine, overzealous alignment filters nuking half the data, starving the curriculum, dial sensitivity gradually.
My gotcha is business-centric. Stakeholders comparing raw accuracy lifts against last quarter's KPI baseline without accounting for model drift, set expectations early that gains may plateau.
Excellent reality checks. To wrap, a Winston Churchill quote fits. To improve is to change. To be perfect is to change often. SQLM operationalizes that continuous change. Just make sure your guardrails change with it. Thanks for sticking around for this technical deep dive. See you on the next episode of AI on AI. Fantastic roundtable. Let's land the plane with rapid-fire takeaways. Then I'll stitch them into a closing montage.
Big picture, SQLM slashes data curation dependence by letting the model eat its own cooking. And for execs, that translates to shorter time to market under tighter privacy regs.
Technically, the asymmetric self-play loop, with shared weights, KL anchoring at 0.001, and majority vote or test pass rewards, is the core innovation. Everything else is plumbing to keep that loop stable.
Implementation gem, role tag prefixing plus LoRa adapters yields sub-15 GB memory footprints, so even mid-tier GPUs can host both proposer and solver personas.
Operational insight. Treat proposer update frequency like a thermostat. Every 5 PPO steps keeps the curriculum spicy yet solvable, which our monitoring showed boosted solver accuracy by roughly 14% on arithmetic tasks.
And strategically, think of SQLM as a self-generating R&D lab that spins up synthetic scenarios, fraud, HR, legal, you name it, while gating risk with lightweight verifiers or fairness hooks.
Let me synthesize. 1. Autonomous curriculum beats static datasets. 2. Generator verifier gap decides your reward scheme. 3. Parameter-efficient fine-tuning democratizes deployment. And 4. Business wins come from faster iteration plus privacy compliance. The 80-20 rule applies. 20% prompt and reward engineering drives 80% of the gains. Exactly. And the contrarian reminder, track drift and bias, or the loop reinforces its own blind spots. A weekly audit closes that gap.
One last heuristic. If innovation index 0.2, regenerate problems. If entropy 1.0, raise temperature. Simple dashboards keep teams ahead of collapse.
Well said. Listeners, whether you're tuning knobs in the model stack or steering corporate strategy, SQLM offers a blueprint for self-improving AI. Change is the only constant, and with self-play, change becomes the engine, not the hurdle. Thanks to all our experts. Catch you next time on AI on AI.